Okay, now let us consider this example for the matrix chain multiplications. Now I will change the matrix names. So like P, Q, R, and T. And the P dimensions are 5, 4. Q dimensions are 4, 6. These two are same, then only matrix multiplication is possible. Q dimensions are 4, 6 and R dimensions are 6, 2. Yes, these two are the same. And R and T, like R is the 6 by 2 and T is the 2 by 7. Yes, problem is solvable. Now, how many total dimensions we have? So better to note those dimensions. So D0, D1, D2, D3, D4. We have the four matrices: matrix 1, matrix 2, matrix 3, matrix 4. So remember, when we have the n number of matrices, the dimensions must be the n plus 1. And total dimensions, my dear. And dimension number begin with 0 to n. So 4 matrices, dimension 0 to 4. So what is the first dimension? 5. Second dimension 4. Third dimension 6. Fourth one 2. And the last one 7. Okay. So totally these are the 5 dimensions we have. And we are talking about now dynamic programming. We know the dynamic programming is going to be find all possible solutions. And we know how many possible solutions with four matrices for the matrix multiplications. So according to that formula, 2 into n minus 1 c combinations of n minus 1 by n. So totally we have the 5 different possibilities. Okay, so those 5 different possibilities are okay. So these are the 5 different possibilities we have. So out of these 5, we don't know which possibility gives us the minimum number of multiplications. We want to find that. We want to find the minimum number of multiplications, and also we want to find for which possibility we will get the minimum number of multiplications. Okay, so for that purpose here I am going to be use the tabular method. Already we know the tabulation method as well as memorization. Here I am going to be choose the tabulation method. So this is my table. Like rows and columns I have. Okay, ignore this one. So my rows are 4 rows, four columns. My I is this one and J is this one. So first I will write the each and every cell value like m of 1 1, m of 1 2. So my dear, later I will we are going to be fill those values. Okay, so first I will write the each and every cell value with respect of row and column. So multiplications needed for 1 1, multiplications needed for 1 2. So still it gives the more size. Multiplications needed for 1 3, multiplications needed for 1 4. In the same way, multiplications needed for 2 1, multiplications needed for 2 2, multiplications needed for 2 3, multiplications needed for 2 4, multiplications needed for 3 3, multiplications needed for 3 4, and multiplications needed for 4 4. So mind you, we know if the I value must be either equal or less than. If I value is greater than the j, not possible to do the matrix multiplication. So here second matrix is not going to be multiplied with 1, but first matrix is multiplied with 2. Yes. So the matrix is A1 and A2, A3 like. A1 is multiplied with A2, but A2 does not multiply with a A1. Back in chain order only the matrix multiplications are possible. That is the problem statement already we discussed. So that's why 2 1 it is not possible, 3 1 not possible, 3 2 not possible, 4 1 not possible, 4 2 not possible, 4 3 not possible. Okay. So we will find the matrix multiplications needed for 1 4. Here the number of matrices are 4. We want to find the matrix multiplications for 1 4. So nothing but our I is here, our I is 1 and j is 4. Okay, so I will tell you the shortcut. So first you will find the differences between j and I. J and I, nothing but j minus I. You will find the difference. If the difference you must be traversed from increasing order, nothing but first you will find the 0. Then only will move to the j minus I, difference is 1. Then only will move to the j minus I, difference is the 2. That means first we will find the MII. Nothing but this is the I and this is a j. Nothing but 1 1. So what is the meaning of 1 1? That means first matrix is multiplied with the same. Nothing but multiplications needed to get the first matrix. First matrix is itself. There is no multiplications we needed. My dear, don't assuming that is the meaning of first matrix is going to be multiplied with the first matrix itself. That is a wrong assumption. So the number of multiplications needed for the first matrix multiplication is 0. In the same way for, I will better to change the color. Okay. So 0, 2 2 also 0, 3 3 also 0, 4 4 also 0. The reason is number of multiplications needed for only matrix 1, only matrix 3, only matrix 4 and so on. Okay. Later we will go with difference 1. Difference 1 in the sense first row nothing but 1 2, 2 3, 3 4. Nothing but 1 and 2 multiply. Then 2 and 3 multiply. Then 3 and 4 multiply and so on. Nothing but the difference 1 1. Only 1. J and I. So whenever you want to find M12 value according to recursive equation, now you will apply. I is not the j. The reason is I is 1 and j is 2. So not the j. So if it is equal j, then it is 0. But when it is not equal to 0, we must be observe whether I less than j or not. Yes, I is 1 and j is 2. So that's why 1 is less than 2. You must be apply this formula. What is this when? Okay, so you will write the formula for it. M of 1, 2 we are calculating. When we are calculating for M of 1, 2, according to this formula, what it becomes? Minimum of M possibility. What is our K possibility? K must be less than or equal to I, but must be less than J. Okay. What is our J value? 2. What is our I value? 1. So, K is possibility, not the 2 and 1 or more. Now clearly observe. When it is not the 2, 1 or more, it has the only one possibility, that must be K equal to 1. That must be K equal to 1. Okay. So, these values as well, these equations must be stored, must be maintained. Then only you will find the which possibility it gives the minimum number of multiplications. Okay. So M12 K equal to 1, then it becomes M of 1 1 plus M of I is 1, K is 1. Here K is 1, K plus 1 is the 2 and J is the 2, M of 2 2 plus. Now dimensions, nothing but the projections. Already I told you dimension or projection, both are the same. So P0, P1, P2, P3 and P4. Nothing but Pi minus 1. What is our I value? 1. Nothing but P0 into Pk. What is our K? 1 into J. What is our J? 2. Nothing but P2. So, what is the value we are getting here? Minimum of M11. What is M11 value? 0 plus. What is M22 value? 0 plus. What is the P0? 5 into. What is the P1? 4 into. What is the P2? 6. Nothing but 5 into 4, 20. 20 into 6, 120. So, here we are getting the value is 120. Is it clear? Now, in the same way, you will go with the difference one. That is nothing but M of 2, 3. Nothing but minimum of, so better to change the pen color. M of 2, 3. So, the same minimum of the possibility of K is only 2. The reason is either equal to I or more than I, but must be less than J. So, M of I, K. I is 2 and K is 2 plus M of K plus 1 J. Our K is 2, 2 plus 1 is 3 and our J is 3, 3 plus the same projections. What is our projection? P I minus 1. What is our I? 2. So P1 into Pk. What is our K? 2. So P2 into Pz. What is our J? 3. Nothing but P3. So now minimum of, so M of 2 to 0, M of 3 3 0, and what is the P1 value? 4 into, what is the P2 value? 6 into, what is the P3 value? 2. So nothing but 0 plus 0 plus 4 into 6, 24, 24 into 2, 48. Nothing but 48. So then you will write M of 2 3 value is the 48. Okay, so then go for the next difference value with 1. So with 1 we have one more, that is M of 3 4. What is M of 3 4? The same minimum of K value must be equal to I and must be less than J and also more of I. But here we have the only one possibility, K is the 3. So M of 3 3 plus M of 4 4 plus MP of I minus 1. What is our I? I is the 3. 3 minus 1, 2 into Pk. What is our K? 3. So P3 into Pj. What is our Pj? 4. Nothing but P4. So which gives the minimum of, okay, what is M33? 0 plus, what is M44? 0 plus, what is P2? 6 into, what is P3? 2 into, what is our P4? 7. Nothing but 12 into 7, 84. So 6 into 2, 12. 12 into 7, 84. So which gives us the 84. Nothing but M of 34 is the 84. Okay. So as of now we calculated M12, M23, M34. Then go for the next with the difference 2. As of now we calculated with the difference 0, then with the difference 1, then we will move to the with the difference 2. So with the difference 2, then the first possibility is M13. So M13, so the minimum of, here observe, K value is, according to our principle, equal to I or more than I, but must be less than J. So here I is 1 and J is 3. Nothing but the K possibilities are either 1 or 2. So if K equal to 1, our equation becomes M of Ik, nothing but 1 1 plus M of K plus 1, nothing but 2, J, nothing but 3 plus, here our K is 1, my dear. I am talking this K is 1. And what is the projections we have? P of I minus 1, nothing but I is 1. 1 minus 1, 0 into K. What is our K? 1. Nothing but P1 into Pj. What is our J? 3. Nothing but P3. Or if K equal to 1, this is the equation. In the same way, for K equal to one more possibility also there. That is nothing but if K equal to 2, so I want to change the color for our convenient. If K is 2, which becomes M of Ik, nothing but 1 2 plus M of K plus 1, nothing but 2 plus 1, 3, and J is also 3 plus, now focus, P of I does not change. I minus 1, nothing but 0. K, previous K is 1, now our K is 2, nothing but P2 into Pj. Pj also does not change, nothing but P3. Okay, so now find the values. So minimum of, we know M11 is the 0 plus M23, earlier we calculated. What is that? 48 plus, so what is the P0 value? 5 into, what is the P1 value? 4 into, what is the P3 value? 2, comma. One more we have M of 1 2. We know the value of M of 1 2. What is that? 120 plus M33 0 plus, what is the P0 value? We have 5. And what is the P2 value? 6. And P3 value 2. So now the minimum of, so 5 into 4, 20, 20 into 2, 40, 40 plus 48, 88, comma. Now observe. So 120 plus 5 into 6, 30, 30 into 2, 60, 60 into 60 plus 120, 180, which is minimum 88. So for which k value we are getting this one? So you will remember that k value, and M13 is the 88. Okay, so as of now we calculated with the difference 2 only one, that is the M13. We have the one more also with the difference 2 of J and I, that is the M of 24. Nothing but now we will find the M of 24. So M of 24. So this is for this one also, I is the 2 and J is the 4, K two possibilities, either 2 or 3. So the minimum of, if K is 2, what is the equation we have? If K is 2, M of Ik, nothing but 2 plus K plus 1, M of 3, and J is the 4 plus projection of I minus 1, nothing but 2 minus 1, 1 into Pk, nothing but P2 into Pj, nothing but P4. And if K is 3, if K is 3, our equation becomes M of Ik, nothing but 2, 3 plus M of K plus 1, nothing but 4, and J also 4 plus first projection does not change. Second projection Pk, what is our Pk now? P3, and third also does not change, nothing but P4. The reason is Ij does not change. I minus 1 J, I minus 1 J. Now calculate the values. So what is the value of this one? So minimum of M220 plus M34. Already calculated M34. That is nothing but 84 plus P1. What is the P1? 4 into P2. 6 into P4. 7. And one more we have. What is M23? M23 already we calculated. 48 plus M440 plus P1. 4 into P3, 2 into P4, 7. Okay, so now you will find the actual value. So minimum of, so 4 into 6 into 7, 42, 42 into 4, 168 plus 84. So 84 plus 168. Comma. So 48 plus 4 to 8, 8 sevens are 56, which is nothing but the minimum of. So here we have the 12, 14, 15, 252, and here we have the 4, 104. So the minimum is the 104. 104 given by the second equation, nothing but second K. So we'll remember that. So here we have the 104. My dear, be careful while doing the calculations. So now with the difference 0 we completed, difference 1 also completed, difference 2 also completed, but the finally we have J minus 1 is with the difference 3. The reason is 1 4, that is the last cell we have. So M of 1 4, m of 1 4. So here we have the three possibilities for the k value. K is either 1 or 2 or 3. So if k equal to 1, minimum of m I k, nothing but 1 1. My dear, I is 1, j is 4 and k is 1, plus m k plus 1, nothing but 2 4, plus what is our dimensions, projections for p of I minus 1 0 into pk p1 into pj p4. That is the first one. If k equal to 2, if k equal to 2, what we have, m of ik, nothing but 1 2 plus m of k plus 1j 3 4 plus projection of I minus 1 does not change, pk only changes, p2 and j also not change. And for the k equal to 3, one more we have, k equal to 3, m of ik 1 3 plus m of k plus 1 j 4 4 plus first projection does not change, second projection is the 3 and third projection does not change. Okay, so now what is the values of m11 we know, so minimum of 0 plus m24 already we know, what is the m24 value, 104, plus we know the p0 value, p1 value and p4 value. So once again copy the same values here. Okay. What is the p1 value, sorry p0 value, 5 into p1 value 4 into p4 value 7, comma, my dear, p0 p1 p2 p3 p4. Okay, one more we have m12, we know the value of m12, what is the value of m12, 120 plus value of m34, we know the value of m34, what is that, 84, plus p0 does not change, 5 into p3, what is the value of p3, 2 into 4 also does not change. So coming to this one, third one, k equal to 3, what is m of 1 3, m of 1 3 from our table 88 plus 4 4 is a 0 plus, so first projection does not change, p3 value is 2, sorry my dear, for the previous p2, what is the p2 value, 6 not the 2, so kindly be careful while doing the calculations. Okay, I hope all you are following it, and p4 does not change. Okay, so now once again you will find the minimum of, so 5 into 4 20, 20 into 7 140, so 104 plus 140, comma, and here 120 84, nothing but 204 plus 5 into 6 30, 30 into 7 210, comma, and here 88 plus 5 into 2 10, 10 into 7 70. Okay, so once again you will find. So the minimum of on so 104 plus 140, nothing but 4, 244, comma, here we have the 4, nothing but 414, comma, here 8, 158. Okay, 158. So what is the minimum? 158. 158 given by the third equation, nothing but for third k. Okay. So in this way we are getting the final values. M14, finally we have the 158. My dear, the remaining calculations, be careful while doing the calculations. Maybe the if you are properly taking the projections, then there is no problem. Otherwise it may be mislead the possibility. So finally we get the possibility for last one, nothing but 158 is given by which k value? K equal to 3. My dear, now the total number of minimum multiplications we needed for the given example is the 158 number of multiplications. Now we want to find what is the matrix chain for it. So for this one, be careful while finding the solution for it. So k equal to 3. So k equal to 3 in the sense this equation it gives the result. So in this equation clearly observe what is that? M13 1 M44 M13 in the sense. So this is the A4, nothing but the fourth matrix. According to our, what is our fourth matrix label? T. Our matrices are P, Q or T. So the observe M13 and M44. So M13 is nothing but that is the one parenthesis 13 and 44 is the itself, nothing but into T. Now go for the M13 label. So in the M13, my dear, go for the M13 label. So this is our M13. So in the M13, for which k value we are getting as a minimum? K equal to 1. So what is that equation? This one. What is that equation? M11, M23. Clearly observe. So ignore about the first matrix. Nothing but the P that is multiplied with 2, 3. Nothing but what is our 2, 3? Q and R. Okay. So 1, 1 and 2, 3. So go for the 2, 3. So what is our 2, 3? For the 2, 3, we have the only one. So there is no possibility. You must be considered as the 2 and 3. Nothing but Q and R. So for this possibility, we will get the minimum number of multiplications. That is the 158. That is the 158. Okay. So this is the minimum number of multiplications we have. Okay. So my dear, this is about the general matrix multiplication algorithm. I think you are good at this part. And this is the matrix chain multiplication. If you are clearly observe, for this one, here we have the first matrix row, second matrix column, and this one is either first matrix column or second matrix row. So for this one, Okay, why we are considering this length in the sense, in our table, we are not willing to fill these things, so this is ignoring. The reason is, if I value is same as the j, we are considering with 0. Otherwise, if the I is less than j, then we are calculating. Otherwise, if I value is greater than j, then we have no right to be calculated. The reason is the multiplication is following in the chain system. Okay, so this is the one example. So all of you do it, like you feel homework and find the possibilities. My dear, here don't feel the j and the I. So that my actual table is this one, like this is the I and this is the j. So like 1 1 1 2 1 3, okay, 2 2 2 3 3 3. Okay, if I'm going to be rotating my table from this position, then it becomes this is the j and this is the I. Okay, don't get the confused. So these two angles are the same. Okay, so 1 1 1 2 1 3 1 1 1 2 1 3 2 2 2 3 and 3 3. So my dear, in your examination, not need to maintain our table in diagonal format. You will write the same table. You will get the full mark. So the table view is not important here. So you will write this table. Not need to uh, write our table in this format. Okay, and this is the one more example. My dear, here the examiner directly gives us the projections for us. Nothing but five projections. Five projections in the sense four matrices we have. Let us assume those four matrices may be the A. This is the A dimension, B dimension, C dimension, and D dimension. 40 20, 20 30, 30 10, and 10 30. Okay. So thank you one and all.